it's actually it's a Goddard thing.
I'm calm.
The mirror team had its share of problems too. Early on we had some structural problems. In a couple of cases, mirror assemblies did not pass vibration testing, which simulates the rigors of launch. We went in and made repairs to the assemblies and retested successfully.
The X-ray telescope quadrants are ready for more testing and final assembly.
You're seeing the edges of the foils in many, many arcs like that. That's the 175 nestings. So then you got a quadrant. Now we're going to do some optical testing with that, and then we start doing X-ray testing with it. And so what we're looking for is to contain the photons in as small a circle as possible.
The better the focus, the more photons will arrive onto the XRS.
So the process is done again in optical and white light by putting the 4 quadrants on the ring and then looking at where each quadrant projects its image and adjusting these until they all project to the same spot.
With the assemblies complete, the telescopes can be packed and sent to Japan for further testing and final assembly onto the spacecraft. It's been a tough few weeks for the XRS team, but their determination and drive to stay on schedule pays off.
So we're going to deintegrate the FE-ADR this morning. We should be done in about an hour and a half. And then that ends this series. And then we're on to the cryostat integration. Back where we should be. People are a little bit happier than they have been over the past few weeks because we made a new schedule after we had the accident, the damage to the test door, and it looked like if we really worked hard, we could get done in time to deliver in mid-March, which is when we need to deliver in order to launch on time. We've actually gained on that schedule. We're 6 days ahead of that schedule right now, and that has some slack in the schedule as well. So we've got a little bit of room now to breathe. So everybody's feeling a little bit happier. It's really nice to be done with this calibration, the interim calibration, and going back into the real flight unit.
It's time. Time to pack up the XRS instrument and ship it to Japan to be assembled onto the Astro-E2 spacecraft.
The key point here is to not break anything. We've gotten to the point where we have no time left. We've got to get it in there and over to Japan in the next couple of days. We don't have time for any mistakes. Everybody's working very hard to get this thing ready to go and out the door in time. We have to keep the instrument cold during transport, and so we have something like 450 pounds of dry ice that they're going to put in this thing. Dry ice is frozen carbon dioxide. It's a lot colder than regular ice, but the key thing is it doesn't melt. It just turns back into CO2 gas. And then we'll scoop most of it out at the other end because that's actually enough to last a lot longer than we think we'll need. Again, putting in lots of margin so that even if things go wrong or something goes funny, we got plenty.
The telescopes and XRS instrument go to Japan, but our story doesn't end here. In Japan, the instruments will be assembled into the Astro-E2 spacecraft, where everything will be rigorously tested again. Astro-E2 will then be placed atop a Japanese M5 rocket for ultimate launch into orbit. Following Japanese tradition, once safely on orbit, the spacecraft we know today as Astro-E2 will get a new name. That name will remain a secret until then.
And this is the LCDR on channel 1, checking all stations are manned and systems ready. CLCDR?
Ready.
Talker?
Ready.
Timer?
Ready.